This is so good. Do you remember this thing? It's like when I went to school, this was insanely popular. It was like went viral, I think, in like 2003. Okay, let's go to Altium. Today I'm going to explore a way that I found to manage the library in Altium, which I think is the best way so far. So it all started with me finding this little pane here called part search. And previously I was always like going to Explorer and I would like search for parts here and then I wouldn't find them and I would create my own parts. Well, I haven't used Altium that much. It's like I'm pretty new to Altium. But then I discovered this part search, and this is really useful. So let's say that I've just started a project, and this is a completely clean project. And the first thing I will do is I will add a project library. So I will add a footprint library and a component library. And that's where I'm going to put all of the components that relate to this project. And also, if there are other components that I've used before in a different project, I would import that library as a standalone library with components that maybe I'm kind of more sure that they're correct and I can reuse them. And then any new component I will put in this project related library. So let's add a new library. Add existing, let's see, add new to project. Yes, that seemed right. And then I will add a schematic library and I will add a PCB library. Let's see, go to that and I'll add a PCB library as well. No, that's PCB. I don't want PCB. Let's see. Remove from project. Yes. Add new to project. Let's see. So the PCB library is where I'm going to be putting all my footprints, and the schematic library is where I'm going to be putting all my components. Why did this not end up in the libraries? That was really annoying. Okay. Anyway, so we can rename this to... Okay, so I cannot rename this. Interesting. Maybe I can click on it and rename it. Or maybe I can just save it and rename it. So let's see. So I would usually call this like the same name as the project. For this video, I wouldn't bother, so I'll just save it, and I will go to the schematic library and I'll save it as well. So now we have these two libraries, and now it's time to like add components. So let's say I'm gonna add, I'm gonna start with like an IC. We can go to let's say we're going to build a power supply, because that's what I've been doing like several other videos here. So I need a component called like TPS 53360, for example. Now I can go to part search first, and I can enter the name of the component, 54 like 360, and this is going to search for like a bunch of suppliers, and this is going to output a list of like any component that Altium can find. And Altium supports a lot of suppliers, so this is really useful. Now it's not even like just finding the parts that's useful. What's really useful is these fields that you find here. So if you go down here and you can see all of these fields, and there's like insanely many fields, and also the documents, the links to the documents. The prices, obviously, that's kind of useful, but that's not, you can actually live without prices. As long as you have the product number, as long as you have manufacturer number, you can always get the prices. Now, I'm not going to be entering those fields manually. There's like no way I'm going to enter all of these fields manually when I create my own component. But then, Altium has a function. It's called import into library. In order to have this option here, you need to have the library open. Like if you're in a schematic sheet and you right-click here, you're not going to see this. So you have to have the library open, and you can right-click and then import into schematic library. So this is going to import all of these fields. And the most important thing here is the manufacturer number and the manufacturer, and this a lot of other fields that you can export into any report that you're going to create later, like the BOM report, for example. You can always export any of these fields into the BOM report. So I go to my schematic library, and I have this component now. I can delete that default component. Let's see. Actually, I want to see if you can actually see that, because I have the camera there. So I need to move this one out here, maybe like that. That's better. Now, this component is not complete because it still doesn't have a footprint, and it still doesn't have like settings for the designator. So we can just enter the standard settings, and what do we want to have as a comment? We want to have the name of the regulator. And we also need the schematic symbol. For schematic symbol, I will always go to Explorer, and I'll search for the component and see if I can find it in the vault. If I can find it, then I'll take the schematic symbol from there. If I cannot find it, I'll draw the schematic symbol myself. Now, in this case, I can find the schematic symbol in the vault, and I can also find the footprint in the vault as well. So I can right-click on this, and I can import this into my workspace. When I do that, I can copy the schematic symbol, and I can paste it into my own component, so I don't have to do it myself, which is kind of like a time saver. It's really useful. So let's see. I'm gonna go here, and I'm gonna paste this, and then there is this footprint. Now, one thing that I really don't like about Altium Vault components is that the footprints, they're not named in any standard ways. Like, they're not IPC footprints. They're footprints that are pretty much random. Like, Altium has, obviously, all of these components are created by people that don't really follow any standard. They're not really, they follow their own standards. But I prefer to have the components and the footprints in a more standardized way. So the first time you do this takes a little bit of time, but luckily you don't have to do this every time you reuse the component later. So you only do it once for every component. So I'm going to go and create this footprint. So to do that, I need to open the datasheet, and I can actually do that directly from the component here. I have the datasheet, and I'm going to see what footprint this chip has. Here we have, so it's an H SOIC. It's basically like a SOIC, but with a thermal pad on the pin number 9. We have a thermal pad there, so we can go to our PCB library, and we can add a new footprint. I'm gonna delete this one. Come on. Can you delete? Oh, maybe I cannot delete it because I didn't have any other footprint. So like, I can delete that one. Yes, I can delete that one. Let's modify this one. So, or actually, let's add a new footprint, and then we can delete that one. So I'm going to add an IPC compliant footprint. This wizard is really useful. I find it so useful. It's like it can create any footprints that almost any footprint that you can think of. Like really custom stuff you really have to create yourself, but like standard components, this has so many different components, and you can just pick the one like a standard wizard, and then you customize the component from the datasheet, from the values that you can see in the datasheet. So let's see if we're going to create a SOIC package, and we're going to go and enter the values for this SOIC package. Let's see if we can find the values. We can find the exact footprint of this component. Usually it's like in the end. So here we have the exact footprint, and here we have also the landing pattern. So what the wizard is asking us is, what is the length of the component, which is 5 millimeters, the D. Actually, I'm going to start with H, just so that we can follow each field in order. So H is the distance across from pin to pin there. It's 6.2 millimeters. what am I doing? I'm so stupid. I was thinking about D. Oh, I have to enter this into the H. Let's see, 6.2 millimeters. So then we go to A, and A is the height of the chip. So the height of the chip is like really useful only for 3D visualization of the board. So it's 1.7. We go 1.7, and we can see the chip here. A1. A1 is the right. So that's like 0. I think 0.15. And E is the width of the package. It's 4 millimeters. Like that. Let's see. And then we have the length of the package is 5 millimeters. So it's starting to look like something that really resembles this SOIC package. It has 8 pins, and lead width is 0.51. It's right here. So we're going to go ahead and enter that. 0.51. Length range is the L. The L is that one. Can you see this? Yes. Let's see. Put it up there. Go like this. Yeah. Length is, let's see, there. The L, 1.27. And then we can go to next, add thermal pad. This allows us to also add the thermal pad, and we can find the dimensions for the thermal pad right here. It's 240 times 310. So E2 is 240, and D2 is 3.1. I can rotate this, and I can see the thermal pad. It looks perfect. So if you look at the picture of the footprint that they have here, it looks pretty much like this. So it's perfect. So this is example board layout via pattern, and let's see. And this is kind of like recommended landing pattern. So we can probably customize this a bit more. Let's see. Calculate values for S. No, I don't need to customize that. Let's see. I don't need to customize that. Fabrication tolerances. Right here. So we can either use the calculated values, or we can customize this. And we can actually customize this exactly like they recommend in the datasheet. So 0.45 is the width of the pin. 0.45. That's really thin. Interesting. Let's see what this looks like. So Y1 is the length of this, 2.15. Am I actually doing the right thing here? Let's see. Yeah, there are other stencils as well. Like this is the 127. Right. And you have X and Y. Okay. Fair enough. X2 is, let's see, X2 is the, right, so that's the thermal pad, 310, 240. Right, 310, 240. Pad spacing is C. Pad spacing. Right, okay, it's that spacing, 5.75. That's interesting. They're so long. We don't need to have them that long. Okay, so in this example, they're using 2.2 times 0.5, and here they're using 0.45. So yeah, they seem to be using those long leads. Okay. Rectangular, rounded, yeah, that's fine. And P is not included in this. Silk screen, let's see. So yeah, I cannot visualize this, I think, the mechanical layer. That would be useful to visualize, just to see how much space they reserve around the IC. But that's it. So I create this and I get a footprint that is named properly according to the IPC standard. This is very useful. So this looks a bit, this looks so big. I really don't see why they use these big pads here. Okay, let's modify this a bit. I mean, obviously you can change this later. This is just following the data sheet and creating a footprint according to the data sheet. In most cases, the footprints end up like looking reasonable, but I think these pins are too long. Like those pads are too long. But anyway, so let's finish our component. Go to the, let's see, schematic library, and we click on our new component. And the only thing that's missing here is now the footprint. So I'm gonna go and browse into the footprint, and I'll select the footprint. Okay, cool. I got the footprint. Save that, and that's it. So we can go back to the schematic, and we can then go into the libraries here, and we can select our new library and place this component onto our schematic. So now we have done a custom component which we can reuse as many times as we want in any project that we're going to be using this component in. And what I would typically do then is that I would do the same thing even for resistors and capacitors, because the useful thing about creating a separate component for every distinct part that you have on your schematic is that you can then export it into the BOM, and you can get the distinct product ID codes directly in the BOM, which is very useful. So like using a generic resistor is not going to give that. And as I showed in the previous video, before I found this product search part search dialog there, I would be importing. I would be actually setting the product code manually, which was kind of error prone, and it didn't import all the other fields. So that was really it wasn't the best way that I found at the time, but I think once I found this pane, I was really happy that I could import all of these fields. Now we can also search for a resistor. Like, for example, let's take a 10K resistor, 0603, 1%, and we can see all of the resistors. We can sort them by price, and we can find the supplier that we want. And we can go and import this into our library. So for resistors, I would typically name this like res 10K 1%. If you're using different sizes for resistors, like I usually use 603 because I want to be able to solder things manually without a microscope. So I use 603, but you could use, if you have different sizes, you could probably put also the size in the name. Like the ID is completely up to you how you want to name them. You can put a size here like 0603. And comment is what appears in the schematic, so it's going to be 10k 1%. And then we need a footprint. And once again, like, you can get the footprints from the Explorer, from the Vault, but I prefer the footprints that are named properly according to the IPC standard. So I want to create them myself using the IPC wizard. So I'm going to go here and I'm going to add a new footprint for the resistor. Tools, IPC compliant footprint wizard. So this is a chip resistor. So for the chip resistor, we can use this, like, let's see if there's, yeah, there is a chip here. So we enter the size of the resistor. The length is, let's see, 603 is 1508. So it's 1.5 and it's 0.8. And bandwidth range T. That I would need to look up in the datasheet, but we can actually just set this to like 0.2 maybe. No, that's too little. Let's see. Let's put this into 0.4. Normally you would look this up in the datasheet for proper values. Like, you don't want to have the pads. So if you look at this picture here, you don't want to have the pads like outside, or like not completely covering the actual pad on the component, because what's going to happen then when you start soldering it is that if you have solder here and you start heating it up, it's going to drag the resistor to this side. So the resistor is going to like lose contact with this pad if you have any space here between like underneath the resistor, between the end of the pad and the end of the actual connector on the resistor. So that's going to be like a pain to solder later. Chip resistor, the height 0.4. I think that sounds reasonable. We can actually look this up. You know what? I'm going to look this up. So actually, I can go to, let's see. Can I enter? Can I just go and, no, I cannot do anything while this wizard is up. That was a bit inconvenient, but we can finish this. So we save the settings and we go into the parts, and we're gonna go and I'm gonna go ahead and open up this component here. We have the datasheet. Let's see if the datasheet even says anything. Otherwise, we can like search for the. Oh, it actually does say. So this is the size of the resistor. Let's see. 603, 805, and 1206. Okay. Pretty cool. I1 and I2. So it was 0.3. I1 and I2. And the height is 0.45. Okay. So let's go and fire up the wizard again. Let's see. I have to have the PCB library open to get the IPC footprint wizard. So it's going to have the values saved now because I clicked finish there before. So 0.45 here and 0.3 here. That looks more like it. Sometimes you can increase this size, but actually I wouldn't do it here. I would actually do it on the following pages. So here you can specify, for example, the distance between those, and I think you can even customize the footprint later as well. Right here. So here you can customize the footprint. You can actually make it more, you can make it cover a larger part underneath the resistor. For example, if you have a current sense resistor, you want to have as much copper underneath as possible so that it leads the heat away. Pad spacing, I'm going to just leave it the way it is. And it wouldn't let me do that. So I'm going to do like this. I'm going to delete this and rename this. So now we have our resistor footprint. I'm going to be reusing this for any 603 resistor that I'm going to be adding to the schematic. So I don't have to do this every single time I'm going to add a new resistor. So I'm going to go back here and I'm going to click on this resistor and add a footprint. Let's see. Oh, so I didn't save the library. That's why I couldn't choose it. So go back to the schematic library. This is a bit much clicking, I think, for my taste. I have to click through so many different panes just to switch between the PCB library and the schematic library. And that's something I do quite a lot, so I would appreciate if there was a better way to do that. Let's see, so 603, and we're going to go and add the footprint that we just created. We created this one. So, okay. Another thing we're missing now is the resistor, the actual schematic symbol. So we can just search for any resistor, and we're going to get a schematic symbol for the resistor here, which we can copy and paste. This may take some time. I mean, there's a lot of 10K resistors. And we can just pick any one. Let's pick this one. Let's open the schematic symbol here. Clone it. Open it up and copy this. So for passive components, the standard the standard way of doing it in Altium is that the component starts one cell down. So like -1 in X direction, -1 in Y direction. Why that is, I have no idea. Let's go to our library and we open this and we paste this resistor. So for any other resistor that I do, I'll just copy this and paste it into the new component. So we have the footprint and we have all the settings and we have all the parameters. So look at how many parameters you get. Like you get everything you can possibly think of, even the power of the resistor. Like this is really useful when you do your reports later. This is like so much information that you can just export and double check, and it's all bound to this particular component. That's why I think it's important to create distinct components for every single value of every passive component that you have, just so you can have all of this recorded in Altium. And let's go to our schematic. Let's see. And we can then add this resistor. So I'm not going to connect it to anywhere because this is not a real schematic. I'm just showing you how to do this. Let's then go into reports and bill of materials. So let's say you're done with your schematic and you want to generate your bill of materials. You have all the information you need right here. So we haven't annotated the schematic, so we can like go ahead and do it. Might as well do it. Update changes list, accept changes. This is also something I find really annoying. Like I would want to have a shortcut where I just click a button and it does all of this with default settings. So now we can go into reports and bill of materials and we will see the designators R1 and U1, and we have the library references and we have the quantity, and we can also export things like manufacturer number. That is very useful. For example, if you want to buy those components and you want to just place an order at Mouser, for example, you can export this BOM the way it looks here, and you can actually directly import it into Mouser shopping cart, and Mouser will find the components based on manufacturer number, and then it will put a bunch of extra fields here with the current price for the component, with how much they have in stock, etc. So that's very useful. And we can also export things like package, casing. Let's see, case, package. Do we have that? Yeah, exactly. So it's 603 SOIC, and we have there's a bunch of different fields. Like there's so many different fields. Packaging, I think packaging is more like tape or reel, so that's how much that's how they package them when you like buy a lot of them. Operating supply voltage, pretty cool. Like operating supply voltage, you would never enter that manually. Like you would never go through all of these fields and enter them manually for every single component. That's just too much work. Mount, output current. That's very interesting. Like you want to go through your components and you want to just double check that that everything is rated, properly. You can just put a field there, and once you know that your component is correct, and you reuse the same component in many different schematics, you can actually add a bunch of extra custom fields that you then export in this bill of materials report, and then you can double check that everything is correct. Let's see. So yeah, that's basically it. There's so many things you can do with this. And the most useful part of all is that you have everything is saved in your library, and everything gets directly imported into the schematics. You don't need to add in fields manually, and every single part is directly connected to an actual physical part that you can place an order on and purchase. And you have all the data sheets. Like if I click on a component here in the schematic and I go like to properties, I can just directly click on the datasheet for this component. So I have the datasheet right there. I just click on the datasheet and it opens the datasheet. I can go to this chip. I can click on the datasheet. I have a bunch of datasheets here, in fact, which it has imported from different places. So this is just so useful. This is for like reviewing a schematic. Let's say you're reviewing a schematic. You would go to like Navigator here, and you would click on the different different components. You have your resistor, you have your chip, and then you double check that all the nets are connected properly. So just click on the component and go to the properties and click on the data sheet. You don't have to go to a site, or you don't have to go to Google and search for the data sheet and worry about that it's not the correct data sheet. You just go and click on one of the fields, like on the information that is connected to the component. Very useful. So I hope you learned something, and I hope you were able to see everything that I was doing, because my picture of me is just floating around there, and you cannot see some of the things that are behind it. I hope this was useful, and I hope that this helps you be more effective in Altium Designer, like it helped me. Thanks for watching. Bye.